Hey guys, welcome back to another video. Today we're going to be going through a carbon dating example, more of a story problem perspective on some stuff we've already gone through. So for this problem, we have a half-life of an unknown material, which is 12 years, and then we start with 4 grams. How long will it take to decay 77%? So to start out, our solution for this problem will be as follows. I'll say A is equal to the amount present at any given time. And then I want to say, let's see, our change in the amount over our change in time will then be equal to a negative Ka, where K will be our amount, or our rate, excuse me. A will be our amount, as we defined before. So essentially, K is a function of t, so a function of time, or our decay rate. And if we note d over dt, and then this will be a function of t, and then a, this is actually a separable equation. So to separate this, I want to get my a's on one side, and then the t's and stuff on the other, so I'm going to divide this side by a. So multiply by 1 over a over there. And if I multiply by dt over here, and same to this side, and then cleaning this up, we get 1 over a dA is equal to a negative k dt. And now if we integrate both sides, we find that we have the natural log of a is equal to negative kt, because this is just some constant right now, some constant rate. And if we integrate a constant, we just add a t to it, and then we'll have our plus c as well. So if I want to get a by itself, I'm going to need to exponentiate both sides. So in doing so, the natural log and e will cancel out, so then I have an a on the one side. And then this term can actually be rewritten using the logarithm rule. So if we use e to the negative kt, and this can also be rewritten as e to the c. So if you add exponents, you can break these two apart into multiplication. And if you notice, e is just some numbers raised to some unknown number, which is therefore just a number. So we can rewrite this as c. So multiplying this together, we get a is equal to c e to the negative kt. And sometimes the c is often denoted as a, so we have a equals a0, e to the negative kt. Sometimes this looks a little more familiar. So after we have this, what we want to use is our initial condition, which seems a little bit hidden, but we have 4 grams to start. So at t equals 0, we have a is equal to 4 grams. So if we notice, if we plug in a, 4 grams, and at t equals 0, we can then find our a of 0. So if we have 4 grams equal to a of 0, e to the negative k times 0, and then this will just become e to the 0, which is therefore just 1, because e to the 0 is 1. So then we're left with 4 grams is equal to a0. Once we have this, we can now plug this back into our equation and update our equation. I'm going to move it up over here. So we follow up over here, we now have a is equal to 4 e to the negative kt. And then our next step, after we found our a0, is to find our k. We don't know our time or our rate yet, but we do have some more information yet to use. And the next one I'm going to use is my half-life. So half-life, we have, after this period of time, we'll have half of the material left. So if we started with 4 grams, if we take a half-life, we are left with 2 grams. So we'll have 2 grams equal to 4 e to the negative k. At what time? Well, that'll be 12 years, the half-life. And now we can solve for k. So the first step is I'll want to divide by 4. So I'll have 1/2 is equal to e to the negative k of 12 years. Then I want to take the natural log of both sides to get rid of my e there. So now I have the natural log of 1/2 is equal to negative k times 12. Okay, so if we divide by -12 on both sides, we find that k comes out to be a positive 0.05776. Now that we have our k value, and we have our a0 value, we can plug this in and find the time t. Knowing that we started with 100%, we want to find when 77% is gone, or in other words, if we take 100 minus 77, we find that equals 23. So we want to find when there's 23% left over, or 0.23 as a decimal form. So this will be the amount we're searching for now. So if we plug everything into our equation, we have a equals a0 e to the negative kt. If we plug all our values in, we find that 0.23 is equal to 4 e. This is our 4 grams. This will be our amount remaining. Then we have e to the negative k. So our decaying rate 0.05776, and then t. And now we can solve for the time that it takes to get to that amount. First step, divide by 4. And after dividing by 4, we find that we get 0.0575. So then this value is equal to e to the negative 0.05776t. We take the natural log of both sides. On the left hand side, we will end up with a negative 2.85597. And then on the right hand side, those will cancel, so we'll have negative 0.05776t. We divide by our negative 0.05776 on both sides. 76. After dividing by our negative 0.05776, we find out that t is equal to a 49.44 years. And that's how long it takes.